All right, we finally get to the question type where you and I, the network admins, are actually doing the subnetting. No one's doing it for us and then coming back to us later and saying, did I do this right? Or how many valid hosts do I have? Or how many valid subnets? But you're going to see here why Cisco hits you with that kind of question, because you've got to know how to calculate those things in order to do real world subnetting. Because you don't want to be the person in a meeting and someone says, well, how many hosts are we going to have on each one of these subnets? Oh, I don't know. That I don't know is not a really good answer there, especially when you have stated design requirements to meet. And that's what I call this type of question. And in my study guides, I always bold that S, because it's an important thing to remember that you've got to meet all the requirements you're given. Not just one, not just two. If they give you 3 requirements, you got to meet all 3. And here's an interesting one to get started with. Using network 150.50.0.0, you have to design a subnetting scheme that allows for at least 200 subnets, no more than 150 hosts per subnet, and then you're asked what mask allows this and gives you the maximum number of hosts per subnet. A lot of stuff going on there, and I call this really a 3-in-1 question, or even a 4-in-1 question, because there are a couple of things you've got to know even to get started on the question. First off, you've got to be able to look at that network number and immediately tell what class it is, because the class it is tells you what network mask you start with. Because what is subnetting? It's the process of borrowing host bits. We never borrow network bits, but we've got to know how many network bits we have in the mask so we know how many host bits we're starting with. So that's the first thing we got to know. We also have to know how to calculate the number of valid subnets and the number of valid hosts. So we have to know all those things to even get started. The good news is, once you know all those things, which you do, you've seen them, you've practiced them, you've used them, once you have those, a question like this, 30 seconds, 60 seconds tops. It just doesn't take you that long to do. I'm going to illustrate it here. I'm going to draw it all out here, and we're going to start with that network mask. What is the network mask for this number? It's 255.255.0.0 because it's a Class B network. See if our tab works in 4, 5, 6, 7, 8. There we go. I'm going to try and put these zeros down here. Excellent. So this is what we're starting with. And we have no subnet bits because we haven't done any subnetting yet. So we've got 16 network bits. We've got 16 host bits. And what I like to do with a question like this is start with the minimum number of bits that's going to meet my first requirement, which here is at least 200 subnets. So how many bits do I have to borrow to get at least 200 subnets? 2, 4, 8, 16, 32, 64, 128, 256. 8 of them. So, because that's 2 to the 8th power, that gives us the number of valid subnets. So this mask, getting rid of those, and I like this because it really illustrates what's going on with our subnetting. We're borrowing those host bits and turning them into subnet bits by putting a 1 in there. So that meets the first requirement. Goodness, pardon me. So are we done? Is the mask 255, 255, 255.0, or is it /24? It could be either one of those, right? If you're given multiple choice, we've got to know dotted decimal or prefix notation expressions, which we do. I know you know that. I also know you know that this is not the right answer because we have no more than 150 hosts per subnet. Well, if we have 8 host bits left, how many valid hosts per subnet do we have? 254, right? Because you got to do the -2. So we have 2 to the 8th power, 2, 4, 8, 16, 32, 64, 128, 256. Same thing it was a minute ago. 256 minus the 2, 254, and that violates the second requirement. So what we need to do now is what? How can we reduce the number of hosts per subnet? We can borrow some more bits, some more host bits. So what I'm going to do is replace that one with a 1. Yeah, that won't go forward, but that's a good representation. So now we have 9 subnet bits and 7 host bits. So how many how many valid subnets do we have? We have 512. We know we've got that requirement covered. We're way over 200. And the question didn't say, you can't have more than 500, you can't have this. It just said at least 200. Now it wants to know, we need to know how many hosts do we have, valid hosts on each subnet now? 2 to the 7th power. 2, 4, 8, 16, 32, 64, 128 minus 2, 126. So this mask works. It meets both requirements. Now you could look at it and say, well, I could borrow, another host bit and, it would still work because I'd have at least 200 subnets and I'd have no more than 150 hosts. But the question is also saying what mask allows this and gives you the maximum number of hosts per subnet. So that's tying you into one. It's saying, I want you to give me a mask that gives me at least 200 subnets, no more than 150 hosts on any of them, but still as many as I can get. So that's why you want to stop right there. So your mask is 255, 255, 255, 128, and it's also /25. And the reason I mentioned both of those is that if you're given a multiple choice question, it might freak you out because you say, well, what two masks are the best? It's like, what two masks? What do you mean? Well, they're two expressions of the same mask. But that's all there is to it. You're using all the fundamental skills that you've picked up to this point and you're applying them to a real world situation. That's all there is to it. So I tell you what, we're going to walk through another one of these and we'll do that on the very next video. I'll see you there.